Welcome to AWC's Chem 151 or General Chemistry 1 Supplemental Instruction Session. This is for the exam 2 review. We're on the last page and we're covering thermochemistry. I want to make a quick change to this. This is the specific heat. It says specific heat capacity. We don't want to do this. We're actually going to look at the energy released of the candle. Alright, and so I've already done some of this work ahead of time, so you can see what my answer is. And what I'm going to say is, when you look at the energy released, you're going to use the specific heat capacity equation. Plus or minus Q is equal to mass in grams times specific heat times change in temperature. And because we know that this is in joules per grams degrees Celsius, we know that the mass is in grams, the energy is in joules, and the temperature is in degrees Celsius, unlike a gas equation in which the temperature must be in Kelvin. So we'd first find the specific heat capacity of water, because that's the information that we have. So we don't know what Q is. It could be plus or minus, but we do know it's 175 grams because it's given. We also know that the specific heat capacity is 4.184 joules per grams degrees Celsius, something to know, to memorize. And our change in temperature, T final minus T initial. Plug that into your calculator, we find that it's 47,812.66 joules that water gained. Now, if something gained it, something had to lose it. So we know that the candle lost 47,812.66 joules. You would not be able to find the specific heat capacity of the candle unless I give you more information. So it shows the initial temperature of the candle. And because the fact that the mass changed, you would have to do something specific. So we're not going to find the specific heat of the candle. What we are going to find is the specific enthalpy. So let me draw this off. With our specific enthalpy, what we're looking at is joules per gram, but this is could just be mass, energy per mass. Same way enthalpic density, which we can most commonly see as liters, as joules per liters, is just energy per volume. It doesn't matter what the actual units are, except in the sense that when you're solving for them, you want to make sure that the units you're using are the units that you want to get up in the end, or know that there's going to be a conversion between units. Same thing with, it's not exactly the same with molar enthalpy, because molar enthalpy by definition means it has to have moles in it, but your energy could change. It could be in calories, it could be in kilojoules or joules. Keep that in mind. It doesn't have to be in joules per gram. In this case, I'm choosing to put it in joules per gram, and so that's the way we'll solve it, because I already know what some of the joules will be in it. So because we know that its initial mass is 44.25 and its final mass is 43.11, we're actually going to take that and divide that, subtract 43.1 minus 44.25, and what we get, let me restate that, 44.25 minus 43.11. What we're looking at is the specific enthalpy of the candle. And so what we're looking at is the mass that we have in there, which is 1.14 grams that we have it. The joules, we're going to use that we know that it has this many joules. So that's 47,812.66. We're not putting this in negative because we're not saying that's how much was lost. We're just saying that's the joules that are in it. So if we divide 47,812.66 by 1.14 grams, our final answer will be 41,940.93 joules per grams. And that's how you would find the specific enthalpy of this. I went a little briefer on thermochemistry in this video. I have other thermochemistry videos that I highly recommend that you look at if you're studying for exam 2 and you just need some clarification and you want to look at some practice, or at least at how I solve them. So this concludes those 2 videos I have for exam 2 review, plus my introductory one where I just quickly go over them. I hope you do really well in the exam. Let me know if you have, I hope you do really well in the exam.